Good morning, Algebra 1, periods 1, 6, and 7. It's Mays coming at you from room 308. It's Friday. It is the 22nd of May, perhaps. We are only 1 week out from being academically finished, and then we have finals week. So let's not drop the ball on that one. I intend to post your final on or about the 29th, and you will have until noon on Wednesday to finish that up. That'll be on the 3rd of June to get that done. Wednesday, noon, 3 June. Must be turned in by then so I can get it graded and get it put in a grade book. All right, so what I want to do, I want to have a quick look at Chapter 10. We are graphing a square root function, and once again, that Chapter 9, Section 9.1, I cannot overemphasize the importance of that, knowing how to take square roots and knowing what to do with them. So I'm going to start off with an example here. This is the basic square root function. Looks kind of like that. When you're graphing the square root of x, the first thing you have to remember is that you cannot take the square root of a negative number. You cannot do it in the reals. Now later, when we discover that there's a thing called a complex number or an imaginary number, we have an a plus bi. We're going to do something entirely different. But today, we can only graph and take square roots of positive numbers, okay? So we can only take the square root of positive numbers. So the parent looks something like this. And how did we get the parent? We built a t-chart. If x is 0, the square root of 0 is 0. If x is 1, the square root of 1 is 1. Now notice I only took the positive values. If you would have graphed the negative values, you would have saw like a sideways parabola. But then it's no longer a function because it fails the vertical line test. So for this example, I'm only taking the positive roots, okay? The square root of 4 is 2. The square root of 9 is 3, okay? So if you graph that with your t-chart, you got something like that. All right. So when they talk about the domain of this, x can't be negative. In other words, so the domain of the parent is that x has to be greater than or equal to 0. Take what's underneath the radical, and it has to be greater than or equal to 0, okay? So let's take an example here. Let's go to number 7, and we'll apply that concept. Now you have y is equal to 4 plus the square root of negative x. Now I just got done telling you can't take the square root of a negative number. Oh, so how do we fix that? Well, I remember that a negative times a negative is positive. So therefore, if I only take values of x that are less than 0, that means that I have a negative times a negative, and a negative times a negative is a positive, and I can take the square root of a positive. So therefore, the domain for number 7, x has to be less than 0. Okay? All right. Number 11, f of x is equal to the square root of negative x plus 8. Now take what's underneath the radical, okay? Pull it out. And that has to be bigger than 0. So what do? Well, you can add x to both sides. So now x has to be less than or equal to 8. And I wrote it the other way because I like to read it that way. X has to be less than or equal to 8. Okay? So take what's underneath the radical, and that has to be greater than or equal to 0. Take what's underneath the radical, that has to be greater than or equal to 0. Okay? All right. Number 19. Number 19 says we get to draw a little picture. Okay? This is kind of be important because that's the whole gist of this thing is graphing square root functions. Now, how are you going to graph that y is equal to y is equal to the square root of 3x? Well, once again, I'm going to build a t-chart. If x is 0, 3 times 0 is 0, the square root of 0 is 0. If x is 1, 1 times 3 is 3. The square root of 3 is the square root of 3. If x is 3, 3 times 3 is 9. The square root of 9 is 3. Okay? If x is 6, 6 times 3 is 18. Now, this is where that Chapter 9.1, the square root of 18, well, I recognize that's 9 times 2, and the square root of 9 is 3, and the square root of 2 is just the square root of 2. So when x is 6, y is 3 square roots of 2. All right, now let's graph that. Looks something like that. Okay? All right, number 41. Describe the transformation. Just like when we did absolute values, we had the parent. Same way we did parabolas, things move around just like that, okay? So let's look at this. 41 says y is equal to 1/3 times the square root of x plus 3 minus 3. Okay? Take what's underneath the radical. Set that equal to 0. What's the value of x that makes that equal to 0? That would be a -3. So that means that the starting point, remember if this is the parent, the starting point at the origin, it shifts 3 units to the left. The number on the end, that says take that starting point and drop it 3 units. That 1/3 says you're going to have a vertical compression. Okay? It's only going to be 1/3 as high as it normally would be. So when you graph it, it would look something like that. But I think all they want is just to describe the transformation. So it would be left, the starting point goes left 3, down 3, and you have a vertical compression. It's only going to be 1/3 as high. Or you can think of it as a stretch. It's going to be stretched out 3 times. All right? Okay, so that's a little brief intro to 10.1, graphing a square root function. Okay? So there's the parent, know the parent. All of these can be handled using a t-chart. You can make a t-chart and pick your values so that, I can get at least a couple pretty numbers. Okay? And then all the same rules for moving things around are exactly the same as it was for absolute value in a parabola. But instead of moving a vertex, we're simply moving a starting point. And remember, if it's a function, it must pass the vertical line test. Okay? So therefore, that's why you don't see the bottom half of that. You don't see the negative roots. Okay? Now, if I put a negative sign out in front of this, it will flip it over. Then you will have the bottom half of that. Okay? That's what a negative sign in the front would do. Okay? So we have a little chart that just talks about all of those really cool stuff. And let's see here. Let me get your little chart right here. All right. So this little chart right here, this is on page 545. Okay? That little chart right there, that describes all of the cool transformations that happens here. Okay? So kind of have a grip on that. All right? You can kind of see an example number 3, that negative sign just kind of flips it over, makes a little reflection. Yay. All right. That's kind of what I got for you on 10.1. We do not do 10.2, skip that, and then go to 10.3. 10.3 is the last textbook assignments you will encounter for this year's Algebra 1. Normally we would have finished that chapter, but I'm running out of time. Okay, so for those of you that are still cranking stuff in from chapters 8 and 9, please continue to put it in. Keep putting it in. I will grade it. However, next Friday, wow, I got to turn it off. So get stuff turned in, okay? You got a week. So let's get some stuff turned in. All right, that's all I got for you today. So 10.1, 10.3, finish chapter 8, finish chapter 9. Have a good one. May's out.